We've just seen what is a hard link and what are its properties and use cases. Let's move on and talk about soft links, also called symbolic links or symlinks. They are similar to shortcuts in Windows and behave differently compared to hard links. Let's take a look at this picture. If a hard link is an association between an inode structure and the file name in a directory, a symlink is just a special file type that points to or contains a reference to another file or directory. So a hard link references the file's inode and the symlink references another file. If you delete a hard link, the remaining files point to the same space or inode in the file system, and they will still contain the data stored on the disk. But if you delete the file the symlink points to, the symlink will be useless or broken. To create a symlink, we use the same command as for creating hard links, which is ln, but with the -s option. I'm creating a symlink. ln-s, the existing file, /etc password, and the symlink. In the current directory pswd. I've just created a symlink called pswd to etc password. See how ls-l is indicating that pswd is a symlink and it's also displaying the file it points to. Let's see another example. I'm creating a new file using a redirection. psaux greater than processes.txt. By the way, psaux is displaying all running processes. And the output was redirected to this file. And I'm creating both a hard link and a symlink to the newly created file. So ln processes.txt p.txt. This is a hard link. And now a symlink. ln-s processes.txt and symlink underline p.txt. I'm running ls-li. This is the original file, processes.txt. This is the hard link. They have the same inode number, this number. And this is another file, the symlink. I can access the contents of processes.txt using the symlink. If I move processes.txt to another directory, p.txt, the hard link, will not be affected, but the symlink will be broken. Let's do it. mv processes.txt and the destination directory. I'm moving the file to my desktop. And cat p.txt, the hard link. And it's working. There's no problem. ls-l, it's showing that the symlink is broken. The symlink points to nothing. Cat symlink.txt. No such file or directory. Symlinks are used more than hard links, and we can say that many services like the web server Apache2 use symlinks extensively in their configuration. Other properties of symlinks are: you can create a symlink to a directory, ln-s/etc etc symlink. I've created a symlink to /etc in the current directory. However, you cannot create a hard link to a directory. This will be an error. A symlink can cross the file system. However, a hard link is locally to the file system or the partition. The symlink has its own inode structure. See how the inode number of the file and the symlink are different. However, all hard links have the same inode structure and inode number. A symlink contains only the path to the original file or directory, not its contents. The permissions of symlinks don't matter because the permissions of the target file will be checked. You'll see that a symlink has all permissions. Take your time to practice and understand how symlinks work and how to create them. They are used heavily in real-world applications.